We're going to take a look at some real world examples converting between scientific notation and standard form. So we have the number of movie tickets sold in the United States for a recent year is estimated to be 1,500,000,000. We're going to convert that into scientific notation. So our A value, remember, has to be between 1 and 10. So 1.5 looks good. Times 10 to some power. So let's figure out what that power would be. Starting all the way to the right, start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 1.5 times 10 to the 9th power. Let's take a look at B. The weight of a flea is approximately 6,600 thousandths or 0.00066 pounds. So our A value is going to be 6.6 times 10 to some power. Let's figure out what that power is going to be. So starting at the decimal point, we go 1, 2, 3, 4. So that's going to be 6.6 times 10 to the negative 4. All right, let's take a look at C. The temperature on a January day in Fargo dropped to negative 43 degrees Fahrenheit. So in scientific notation, our A value would be negative 4.3 times 10 to the first power. We don't really need to write that 1 there, but I did it just for emphasis here. So this is an example where why would you even want to use scientific notation? It's not providing any convenience. You can do it, does it mean that you should? In this case, I would say no. D, a bench is 8.2 feet long. Okay, our A value is 8.2 times 10. We did not move the decimal point, so it's to the 0 power. And that makes sense because 10 to the 0 power is just 1, and 1 times 8.2 is 8.2. And again, this is an example where it doesn't really make sense to use scientific notation in this example because it doesn't provide any convenience. Even though you can, that doesn't mean you should. All right, let's take a look at a couple more. This time we're going from scientific notation to standard form. So we have the probability of winning the California Super Lotto jackpot is 5.5 times 10 to the negative 8. Writing that in standard form. All right, so if we're starting at 5.5, we have times 10 to the negative 8. That means our decimal point is going to go to the left 8 spaces. So there will be 1. And then we add a 0 for 2, 3, 4, 5, 6, 7, 8, and then you put a decimal point. And if you want to put a 0 in front of the decimal point, just for clarity, you can. It's not necessary. So there's our number written in standard form. Okay, let's just recount that again to make sure we have 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. So our decimal point will be between the 2 5s. That's where we want it. Okay, last one. The sun's mass is 2 times 10 to the 30th kilograms. Okay, oh boy. So we have 2. Oh, let's get my blue, 2. And we know we need to move the decimal place 30 digits to the right. Let's start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 10 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's put in our commas. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, there we go. As you can see here, these two last examples show you the convenience that scientific notation provides. Instead of writing these numbers in standard form, scientific notation is the way to go. And then the previous two examples, you can see scientific notation would have been unnecessary.